Let's consider the following problem. Consider LC circuit consisting of an AC generator, an inductor of inductance L, and a capacitor of capacitance C connected in series. What is the resonant frequency? Right. Let's draw this picture first. Suppose a diagram like this. Let's put an inductor in there as well. Let's put a capacitor, parallel capacitor in there. And let's draw it all up. Okay, let's basically begin. This is L. This is the capacitance C. This is some voltage V, which is a function of time. I'll pass a current I through everything. Okay, so using Kirchhoff's law, I'll get basically a V cosine omega t, because it's an AC generator, minus L di dt minus Q over C equals 0. Right. Okay, to basically see how this problem is going to unfold, let us now note that I is equal to dq dt. And so this gives me that, move this over to one side, L d squared q dt squared plus q over c is equal to v cosine omega t. Right? So if you look at this, you can recognize this as simply the simple harmonic oscillator. If you don't, divide by L, divide by L, divide by L, you get d squared q dt squared plus L1 over LC q is equal to V over L cosine omega t. Alright, now if you still don't recognize this, you probably recall, write something like this. Here we go. Right, that is the simple harmonic oscillator. This one's a forcing term that will force the simple harmonic oscillator. But it's simply the same as writing this is equal to some F over M cosine omega t. Okay? Alright, so you recognize this simple harmonic oscillator, so that means you can map the same thing. This thing is just omega 0 squared. So basically this implies omega 0 squared is equal to 1 over LC, which implies that omega 0 is equal to square root of 1 over LC, or 1 over square root of LC. Okay? So that is the resonant frequency. You hit this frequency, you get the greatest response. Right? Now let's suppose I swap out the inductor with inductance whose eta times L, where eta is some arbitrary factor. Well, basically, if eta goes to eta times L, what that really means is that omega 0 is equal to, well, I'll call it prime, okay, to denote that's the new omega, is 1 over square root of eta LC, alright? Basically, where you ever see L, you place eta L. That's what happens there. Okay, so how does the resonant frequency change? The resonant frequency changes by 1 over square root of eta, if that is the answer you're looking for. Okay, so basically omega naught prime is equal to omega naught divided by square root of eta. Right? Now, okay, I hope that was helpful.